Of all the irrigation methods, we consider drip irrigation to be the best. It's the best in terms of environmentalism. You're not going to have any waterlogging. That slow, constant drip of water is what plants really need. And what a brilliant idea this is. People are doing this in their gardens. They put out a cup of water, a dish of water. I like that they're recycling plastic bottles instead of putting them in the landfill. So they've got a cup of water sitting out, and then they put a half cut larger bottle over the top, and they close it off. And so the sun comes through and it evaporates the water in the smaller bottle. And as that water evaporates, it rises and condenses again. It's called distillation if you took chemistry. It condenses into water droplets, just like clouds, and then it runs down the sides of the bottle. And so it literally is a drip irrigator that you can put in between your rows of plants or crops. And it, once again, it recycles materials. It requires no energy other than sunlight. And here's the best part. You could use salty water, seawater, brackish water, because when it evaporates, it leaves the salt behind in the dish. What a brilliant idea. Green Revolution, industrial farms. We cut down the trees. We move all the water around. All that work so that we can make enough food for everyone. Problem is that the only people that can afford to do this anymore are large companies. The ones that have all the GMOs and can pay the workers. And it turns out that most small, locally owned family farms are going out of business. There's very few remaining people that have their own farm and actually make a living doing that. The result of all that is that nobody lives in the country anymore. Wow, how do we go from farms to cities all of a sudden? Well, that's the end result. One of the causes of urbanization is that we're not an agricultural society anymore, except for large corporations. Now, we've already talked about this briefly back in August. I mentioned the word sprawl. Make sure you know what that is. Urban sprawl. That'll show up on the AP exam. And the problems with urban sprawl, we're driving around in cars, moving from the suburbs into the city, lots of greenhouse gases. Another one that a lot of people don't realize, landfills. So think of all the trash that's made every single day that gets carted away somewhere, and we don't care where it goes, right? As long as it's not here. I remember a couple of years ago, New York City, they had a city workers strike, and they stopped collecting trash for like 3 weeks. And the alleys just started piling up with trash, and it smelled, and there were rats. And finally, the people were like, we got to get trash collected. It's that important. And we're going to talk about landfills next semester, but what happens in a landfill is this organic material decays. It's the carbon cycle. That's what it should do. And when it decays, it releases a gas, and it releases methane, CH4. And methane is also, most people agree, it's a more potent greenhouse gas than CO2. So landfills due to urbanization are also a contributor to climate change and global warming. Obviously, another big problem in urbanization is that we pave everything. This used to be forest, which we clear cut. And now we've got all these surfaces that do not allow groundwater to soak in. If you were asked about this on an FRQ, boy, do I have a great answer for you. What are the problems with urban runoff? This happened in 2017. We've been seeing much more active hurricane seasons lately, and a lot of people are blaming that on global climate change. I also think that the El Nino cycle plays a role in that, of whether the storms are strong or weak those years. Don't forget about El Nino. It's all connected. But in 2017, this was only a Category 4 storm. We've had bigger. There was one in 1992 that smashed into Florida. Just a monster. Hurricane Andrew. It was a Category 5. This one became the second most expensive hurricane ever. $125 billion in damage. And I don't know if you've seen old pictures from when Katrina hit New Orleans, the flooding, damage there. Houston got it just as bad in 2017. Now, here's the real problem. And city planners, environmentalists had been screaming about this for years. Between 92 and 2010, you can see that the areas around Houston, they converted 25,000 acres of wetlands into housing. They literally built people's homes in a floodplain, knowing that if a big storm hit, they'd be underwater. And why did they build houses there? Because they had to. They had nowhere else to build them. That's urban sprawl. When you start building things in places that you really shouldn't build them. You can see that those wetlands had a capacity of 4 billion gallons, that now that water has to go somewhere else when it rains. Hurricane Harvey dumped 15 trillion gallons of rain when it moved through. So you see the result of that. When all that water hits all those surfaces that are not able to drain, you get massive flooding. They love to give you questions where you're really just interpreting a graph, some sort of chart or data, and that's all this is. They love to give you percentage questions, change in percent. And we're going to do that next semester. There's a lot more math in second semester than first. Okay, so we'll get to the math. Don't worry about that. But really, this one's not really a math question. It seems like it, but it's not. Based on the diagrams above, what is the percent change in the amount of runoff in urban areas compared to forested? Okay, so let's first tackle the diagram, forested, urban. The only number we care about up here is runoff, the one in the middle. All that other stuff does not matter. Okay, it matters, but not to this question. So we see that in a forest, there is 10% runoff. So that means 50, here you see 50% of the water is going into the ground. And in a city, 55% is runoff. It's got to go somewhere else. And only 15% makes it into the ground naturally. Okay, so what's the percent change between these two numbers? All right, now you could go through and do this mathematically, and it's not hard, but just very quick in your head, if we have 10% and we have 100% increase, what would that be? 100%.
20%.
Yeah, 20%. The only one that makes sense here is D. Okay, because 100% increase is only going to get us to 20. So it's got to be much higher than any of those choices. So I was able to just do 100% increase real fast in my head and say, the only one that could possibly work is D. I wouldn't even bother to calculate it. I would just use some common sense to say, oh, well, that's so much bigger that, yeah. All right. I've already mentioned this topic before also, but I wanted to bring it up again with urbanization and the fact that we learned about aquifers and cone of depression and all that yesterday. So in areas especially that are urban and coastal, we see a huge increase in what is called saltwater intrusion. So the groundwater becomes salty because we are depleting our aquifers faster because we have too many people living there by the ocean and in cities. It's a byproduct of irrigation and urbanization. Okay, the next big problem we have is over-fertilization. And I've talked about this as well. So we've got all these people living in cities and they all want their gorgeous manicured lawns. And so they fertilize. Some people do this 3, 4, 6 times a year. They'll go put weed killers and fertilizers on their grass so that it's perfect. And then they irrigate it. They sprinkle it. Those are spray irrigators, not drip. Drip would be a lot better, less runoff. But with spray irrigators, and look, it runs off onto the concrete, impermeable, and all that flows into the sewers, which then goes to the rivers. And all of a sudden, we've got all this extra fertilizer in our water supplies. This causes something called eutrophication, which I'll spell out for you on the next slide. The first major issue here is algae blooms. They thrive in the extra nitrogen and phosphorus that's in the fertilizer. From up above, it's kind of beautiful. The green mixed with the water. But that bottom right picture, that doesn't look so nice. Look at all those beautiful lawns, and all that fertilizer is just running right down into that lake. So they've got a serious algae problem. It's when you have too much of nitrogen or phosphorus, usually, are the main culprits. So most of this happens from urban runoff or agricultural runoff. Gets into the water, algae grows, blocks out the sun. That's the big problem. The algae prevents the sun from reaching deep into the water. When that happens, you no longer have photosynthesis occurring in the water. If there's no photosynthesis, there's no oxygen. And so things that were trying to live in the water choke and die. And that is called asphyxiation. So if you learn anything about eutrophication, know how it starts and how it ends. It starts with too much fertilizer, and it ends, the end product is asphyxiation, choking. So waterways that have algae and too much fertilizer in them, we call them eutrophic waterways. And if they're clean and healthy, they're called oligotrophic waterways. Low nutrients, low algae, lots of dissolved oxygen. So in the United States, we'll put up, the Department of Health will go around and close off sections of water and say, you can't swim in here, there's too much algae, it's toxic to you. These pictures are from when China hosted the Olympics. When people were concerned about the air quality in China, they were also concerned about the water quality. And these are pictures of people playing on the beaches, swimming in algae-infested water. Their beaches are open. They should not be. Now, China was worried about this on the world stage, so they did a huge effort before the Olympics to clean it all up. They actually brought in their army and heavy equipment to remove as much of the algae from the beaches and water as they could. They put on a pretty good show. The Olympics ended up going off without much of a problem. Here's the real problem with eutrophication. It's actually not our lawns. We like to blame that and pick on people in the suburbs and rich people who live at Geist and pollute Geist Reservoir. The real problem is farms. Farms use too much fertilizer as well. And remember, we call this a watershed. The entire middle of the United States, where we have so much farming, it's a giant funnel. When it rains, the water all runs off and ends up in the Gulf of Mexico. Takes a while, but all the rivers are connected. So when it gets there, we have a huge eutrophication problem all along the Gulf shore. They sometimes call it red tide. And you'll have a bunch of dead fish washing up, everything stinks, and they rely on tourism industry. The problem is, we call this a hypoxic zone. Hypoxic means without oxygen. And the problem is the hypoxic zone usually shows up in the spring after we fertilize the fields, and it all washes down a few weeks later. The problem is it's showing up earlier each year and sticking around longer each year. Because of that, we are concerned that one of these years it's going to show up and never go away. We will have a permanent dead zone in the Gulf of Mexico. You can see where the phosphorus and nitrogen come from. Mostly crops. The blue is urban, and you can see they're pretty small. Mostly crops. It's the farms. What's really going on here? The problem is that It's the type of fertilizer that we're using. We got organic fertilizers, things like manure, compost. That's what we should be using. But it stinks, and you got to go lay most of that manually, and you got to tend to it, collect it. It's way easier just to buy some chemicals and spread that around, right? Synthetic. It's what most farms are using now. Now, the good thing about synthetic fertilizers is we can adjust the nutrients. We can target specific nutrients. If we need more nitrogen, we put in more nitrogen. So we can really hone the synthetic fertilizer to specific crops. Problem is, it takes fossil fuels to make and distribute all those fertilizers. And we're totally screwing with nitrogen cycle, phosphorus cycle. We're messing up, speeding them up, ruining the biogeochemical cycles. I'm going to give you an extra credit opportunity here. I'm going to give a bonus point to the first person. Picture on the top left. Does anybody know what movie that is? It's a tough one, maybe. It's an old movie. It's from the 1980s. Nope. I stumped you guys. No clue. Oh, Sawyer's got it. Back to the Future. Nice job. He beat you by just a second, Rebecca. Eli. Maybe I'll hook you all up. Good job. I just showed my daughters Back to the Future for the first time the other day, and they loved it. It was one of my favorites growing up. I have all three. I even like the third one. But as I said, we can target crops. If we want a lawn for a place like Florida, which doesn't get, or it gets very, very hot, we adjust the levels of NPK. And so if you ever buy fertilizer at a store, that's why the numbers are different. Here you can see a lot of fertilizers are going phosphate free. Why are they going phosphate free? For the environment. If we leave the phosphorus out, that decreases eutrophication. So we're actually making an impact. If you're going to fertilize at home, look for phosphate free or low nitrogen, low nitrates. An advantage of using synthetic fertilizer instead of organic is that synthetic can provide more targeted macronutrients to the crops. Yes, that's exactly why synthetic is better. If you read the other three choices, they all actually say the same thing. Synthetic fertilizer remains in the soil longer. No, remember, synthetic fertilizer is the one that runs off. Organic and compost actually naturally stay in. Synthetic fertilizer adds to the soil's water holding. No, it runs off. Organic fertilizer runs off more readily. No, synthetic runs off more readily, right? These three choices are all saying they're talking about runoff. All right, that's it for today. Hang in there, guys. We're getting through it. I'll have information about the final exam very soon. Let you guys know what's up with that. Have a good one.